Can you hear me?
Yep.
Okay. All right, I think we'll just wait just one more minute while I try to sort out. I thought I'd do something a little bit different today, but which was try going through these rules, some of these rules, and coding them up. Almost there. I was just trying to get the code up to okay, let's see if that works. Huh? Good. All right, I'm with my class now. Okay. All right, I guess I'll show you what I'm doing is I've been, I will, let's see, let's switch over. Zoom. All right. Well, how's everyone doing today?
Doing all right. How about you?
Not bad. Not bad. Okay. So yeah, I am working on it. What I thought we would do for the rest as we go through the call by reference, call by name, and call by value was maybe add them into the actual code. So I think some of you, well, I think some of you are so rusty or, in Haskell that you're having trouble with that. But people are also seem to still be having trouble like figuring out how you translate these rules. And but I seem to have broken everything trying to do your homework in 5 minutes. Let's see. Oh, why would it complain about that? Oh, I see. Right. So a store is a map from location to int. And one thing I did in this version is rather than having that silly -1 and -2 thing, I added special constructors called next loc and max store size. And so now I need to go down here and say, okay, this is not a loc. So now I'm looking at Alec and trying to fix Alec. So Alec says, okay, look up in the store the next loc. That's what the bang means for the map. And then insert into that location 0, because this thing initializes to 0. We could modify Alec to take the value to initialize it with, because his var declaration gives you an int, which it may not be 0 to put in there. And then I want to increment the next location. And then I want to insert into the max store size, the max of this and the max of that, and I can get rid of this. I managed to. It's not that hard. I confused myself a little bit. So let's see what that does now. Okay, I still got some errors. One on line 86.
Maybe change loc to be L there.
Ah, good. Thank you. Good eye. Yeah, I've got like, I don't know, how many of you are on here? 25 eyes. We should be able to do this really quick. And then on line 137, what am I doing wrong on line 137? Ah. So, I mean, okay, so this is actually an interesting line of code. And really, I mean, the only thing that was broken there was that you have to reset. So when you come into a block, a begin end block, if you have in your declarations, if you have some variable declarations, you're going to grow the storage. And your next loc pointer is going to go up, and maybe the max, but that doesn't matter, because what we want the max to do is kind of keep track of how big the memory ever got. So we don't want to mess with the max here. But when we exit the block, when you go into a block and you allocate more space, it should behave like a stack. It allocates more space, but when you exit the block, that space is deallocated. And that's what this line here is doing. It's saying, okay, so, the first thing you do is you evaluate the declarations, these declarations, and that gives you a new environment and a new store triple prime. And then what you do is you evaluate the statement that's the body of the block in that store with the environment that knows about these declarations. So that's environment prime there. And that's going to return a new store double prime. But that one still has its next pointer pointing to the end, to whatever was in the original store, wherever it was in the original store, plus however many variables got declared in here. So all you do is you say, okay, reset the next location to be what was in the original store at next location. And so you insert that into the result of this, and now you have a store that has both any updates that occurred in memory from evaluating S, but also has crunched the store back down. So let's see, is that my last error on this? Oh, come on. Oh, I forgot to save it. You gotta save it. Okay. All right. So now I have a version of the code that essentially does the homework. So I have I'd like to be able to run these things. So let's do the I don't know. Does anyone have any questions to start off though from last time, or?
Could you maybe go over the previous homework, the one that was due yesterday a bit? I was struggling with that one.
Okay. Is there anyone that hasn't turned it in yet? Speak up now.
Yeah, I haven't turned it in.
Oh, I can't tell who that is. Who hasn't turned it in? Andrew?
Yep, I know. Yeah.
Okay. Well, can we wait till next time? Or
All right.
don't I have office hours later today?
What time? I'm
Let's see.
busy later today.
Let me see. Oh, I don't know.
Actually going to have to leave before class is over.
Okay. Oh, that's the wrong email. That's why. Okay. I have office hours from 2 to 3.
Doesn't class run until 2:35?
Oh, I'm sorry. Right, from 3 to I'm in Oregon, so my calendar's reset. So yeah, for me it runs to 1:20. Yes, I have office hours from 3 to 4 your time. Sorry, I'm just looking at this. So what do you think? Can we do it then, or maybe next week if you can't make it then?
and next week because I've got
Okay.
stuff happening this afternoon.
Okay. You know, this is going to be very similar, though. In fact, the reason I'm kind of wanted to write the code today was because I thought that people were having trouble writing the code, even though, I don't know, I think there's only about 20 characters that are different between the two files. It doesn't take much to do this, almost nothing. And I just did it, well, aside from trying to make allocate better. I mean, I literally just did it in like 7 minutes or something. It's not hard once you see what you're supposed to do. So let's look at the new ones, and maybe these will help you. You know, let's look at call by reference. What do we need to do to implement call by reference, right? There's two things we need to do. We need to, first of all, add a parameter in the declaration. So we have to add X, and, you know, we could do this, I guess, you know, like a nice way to do this might be able to do, let's see, I mean, I'm not sure whether this is going to work all the way through, whether it's going to work completely uniformly, but so we're going to have to modify both the declaration to take the argument, right? And we're going to have to modify the call. And I'm sort of thinking that maybe we can make like an argument type that kind of depends maybe. So first in here, it's just the formal parameter. Right, so it's just the name of the variable. If you look at the, I don't know, maybe I can figure out how to get both these on my screen at the same time. This is the declaration, and X is the name of the variable. And, you know, this var thing, well, do we need to do it? We don't really need to do that. We don't need to keep account of that unless maybe we want to allow procedures to be called. And so here's the call. And again, it's going to need a argument. And in this case, it's a variable. In the case of call by reference, it's always a variable. Let me see if I can try to maybe, I don't know. How do I get rid of all this? Okay, that was pretty good. Okay, so we can, here's the rule for the call, and we can see that the call is going to have the name of the procedure we're calling and the name, the argument, and a variable to pass in. So we can make that into a variable by passing a string, because that's how we deal with variables, right? And the declaration is going to have to change. Now, this string is the procedure name, and then this string is going to be the formal parameter. So we could, you know, you could, if you're having trouble remembering these kind of things, you could say, okay, the proc name is a string. So we could say proc name. I mean, you could kind of go overboard on this, I think, right? Type And then we want like formal parameter is string. So you have the keyword proc, and then you have the name, and then you have the parameter, and then you have the body. And the body could have the name, the formal parameter occurring free in it, right? So let's see. Have we broken anything? Yeah. Oh, well, because down below we haven't added these in, but that's good. It takes us right to the line, 142. So here's the call. And let me try to get that note back up, and we can look at the call first. Okay, so the call says, so first of all, the statements, so this turnstile here separates to the left of the turnstile is the stuff that essentially doesn't get changed or isn't included in the return type of evaluating this thing, right? If you evaluate this and you transition to that, you don't change the environments. So he puts them to the left of the turnstile. Now, in this case, he has to kind of be sure that he's using the right environments to evaluate S. And so, oh, sorry, I clicked the button when I didn't need to. So what's the first thing he does? He says, okay, look up the variable, look up the procedure name P in ENVP. And so that's what I did here, except that I should have here, maybe we should do, let's do the declaration first so that we know what we're dealing with. Let's look at the declaration. Maybe I can just make this half size and then I won't keep clobbering that thing. Can you see that okay? Don't all holler
Yeah,
at
I can
once.
see it.
Yeah.
I mean, I can't hear it when you guys all start screaming at once. I don't know what to do. Okay. All right, let's see. Let's go look at the declaration first, because that really tells us what we've already got. Okay, so for our declaration, see, he has, remember, our environment includes both the proc part and the variable part. So we've packaged up ENVV and ENVP together. And since you need ENVP here, we included ENVV because we just put the environment in there. So instead of having, we have nothing to the left of the turnstile. And then on the right, okay, we have, okay, it's a proc P, and we want to say the declaration, you give it the formal parameter name, X, and we give it the and then you have S, which we can't make capital because that's how type names begin, but that variable S is this S here. And then DP is more declarations for us. And then he has ENVP, and we have ENV. And since we have made one kind of declaration, there's two constructors for a declaration. Both of these are simply declarations. See, he has a separate rule for procedure declarations and a rule for variable declarations. And so, but when we do variable declarations, we do modify memory. So that means our big step declaration takes a list of declarations, an environment, and a store, and returns the modified environment and store. Procedures do not change the store. So because he separated out procedure declarations from variable declarations, he doesn't need to return the store here. However, this does give him the problem that he doesn't really have an easy way of interleaving variable declarations and procedure declarations. He says you got to do all your variable declarations first and then all your procedural declarations. And we don't have that problem. We can declare them in any order. So anyway, so here's what, and we're going to return this environment. And the only way that this store is going to get modified is not by this declaration, but possibly by something in here. So this, if this was empty, right? If this was empty, we would know that this store is just that. But there could be variable declarations in there. So we're going to include both parts. Okay. And so what does he do? He says, okay, what you want to do is you want to evaluate the DP, this DP thing here, right? The DP is more declarations. So what we want to do is we want to use the big step declaration evaluator to evaluate the more declarations, but we want to do it in an environment that's properly set up. And so what he does is he says, okay, put into the procedure environment. So that's what we're doing here. We're building this environment. Instead of building it right in line with this, we could do this up there, right? We could just insert this thing up here where we see, or down here where we see ENV double prime, but it just makes it kind of unreadable. So here's an environment, and what does this environment know? It knows that P, a procedure P has been declared. So we got procedure P. And now what we need to do is we need to put into procedure P the information, all the information. I forget which order does he do it though. He puts a statement and then the variable name. And then in his thing, he would say, you know, ENVP is all that would be in here. Except he has to actually put both of them in, right? He needs to put both of them in. So we've got them packaged together. So we want to insert the current environment at the time we see the declaration is called ENV. And so what we want to do is we want to update the procedure environment. So that's what we're doing here. We're saying, okay, take the current environment and update the procedure field so that this is what now goes in it. And what now goes in it is you grab the old procedure field from the environment and you update it so that P now has an entry which includes the statement, which is the body of the procedure, the X, which is the name of the formal parameter, and the environment that was in place at the time you saw the declaration. So then we call, he puts it, you know, over the line. We don't have a way of writing down the rules in that pretty way. So we say, okay, evaluate big step declarations. So that's this line. And evaluate the DP is our more declarations. I don't know, would this code be more readable if it said something here like DP, or it actually though is decals. Maybe the more is kind of redundant. But these are the DP. So we're going to evaluate DP. And what environment do we use? Well, we use the environment that's updated like this, but we just built it here in ENV double prime. And what store are we going to use? Well, we don't, this does not change the store. So we just put the store in that we started with. Now, he doesn't use the store here because he's not doing, when he does variables, he uses the store, but we can do variable, this could contain variables. So we need the store. So we say, okay, now evaluate this, and what you're going to get back is an ENV prime and a store prime, and that's what you return. Okay, so Yikai, what do you think? Uh-oh, you're sleeping.
Yeah, I'm here.
Oh, good. Does that make any sense to you? Or does it make sense or no?
Yeah, I'll have to read a book and look at
No,
more.
I'm explaining it right now. If you have a question, you should ask me right now. What part don't you get? You're not going to get it by studying this and studying this and studying this. If I don't think it's better to ask. Be brave. All right. Well, I mean, maybe you weren't really paying attention. So then it's like, you know, okay. Somebody else ask me a question. If you all understand this perfectly, I could hide my screen and give you a quiz right now to translate, you know, the next thing. Do the call, translate that into code. Could you do that in 5-10 minutes?
No, I don't think I could do that, but what you're explaining makes more sense following what's the book with what the code you're implementing was making it more clear.
Okay. That was Isaiah, I guess. Yeah.
I think it makes sense that like see you work it out, step through the functions and show what goes what. But at the same time, I feel like if I were to do that from scratch, I feel like I'd have trouble building it, you know?
Well, yeah, but it really, I mean, in a way, so I've had students that like have taken this class in the past. Like for some reason I had, for a while there, like I had like, I don't know, each semester I had 1 or 2 PhD students from chemistry taking this class. I have no idea why they did that. They didn't know anything about Haskell, but what they learned was how to do the pattern matching to translate this into the code. And you can do perfectly well in this course without even understanding anything except that, which is kind of sad, but but it is true. I mean, it's just being able to read this and see understand what the rule is telling you to do, and then the code is trivial. It's very, very similar, right?
One thing I struggle to remember is just when you look at all those tables in there, all the symbols and trying to track, like I just get lost on what's happening on paper. So then to try and put it into functional programming seems even more difficult. It's like it's hard to follow, I guess.
Yeah. Well, way back when I had a student, one student was really upset. It wasn't this notation, but it was similarly complex in the Schmidt book. Really upset about all the notation. Why do you have to write all this notation on the board? So I don't know. I did one lecture where I wrote out all the English. And, you know, this little specification here would take, you know, a paragraph or two to explain. So once you learn how to read the notation, it's a lot like learning how to program, right? Learning how to read this is like learning how to program, because you gain, when you can read it, you gain like an operational understanding of what that means, and then you see exactly, you can just read from here and get it. I don't know, is there anyone that really gets this? Is there anyone that would be brave enough to say, oh, I get it, this is obvious, I got it, I figured it out? Is there anyone in the class that feels that way? Don't be shy. It would be fine if you did. Nobody does. Uh-oh, that's not good. Oh, I didn't want to do that. Nobody finds it straightforward to read these. Okay. Well, let's keep going. So I think maybe I should, though, I mean, it seems like I almost am getting you to talk, but only a couple of you ever dare.
So if we do like the next one, can we
Yeah.
just like talk it out in English and then I'll take a jab at it maybe?
Yeah. Okay. Let's go to the call. So this was the declaration, but let's let me just try loading it and make sure at least that you know, we didn't make a, that I didn't make a typo. Uh-oh. Yeah. Oh, we're still gonna get that other one because we didn't fix why is that complaining? Oh, did I forget to change the proc name, formal parameter statement? Oh, did I forget to save it? Oh, jeez. Okay, it's not liking line 158. What did I do there? I don't know, maybe I didn't update the record. Yeah. So I need a statement and then a string and then the environment. And now, of course, the call is broken because it should be. All right, so let's go look at the call. That was 142, I think. Okay, so here's the call. And I forget, I guess it was down below. The call was down below. Here's the declaration. And here's the call. I think I can erase whatever. Part of this, now, part of the stuff that he's doing here is stuff that we don't really have to worry about because this is hidden in the the store. And I'll show you why in a second. So you want to call P, and the argument is Y. So I need to fix this. I need to say call P, let's say Y, to make it read almost identical with the store. And we have our environment out to the left here. And because evaluating a command or a statement always just returns just the store, it doesn't change the environment. So he says, okay, go up here and evaluate the body S. So we're going to evaluate the body S, and we're going to use ENV prime. And that's what he does here. He looks up P and he gets back ENV prime and ENVP prime. And he modifies, though, ENVV because at the time, this variable environment is the one that was in place at the time the declaration was seen. And there could have been more declarations after that. And so it keeps track of where the next memory location is. Don't ask me why he did that in ENVV. And for us, it's in the store. So all he's doing here is he's saying, okay, take the ENVV that is in place at the time the call occurs. And first thing is look up the location that's associated with Y, and that's going to be L. And so we make the former parameter name X go to L. And we haven't done that here yet. We need to do that. But this part we don't need to do. He's saying, oh, and by the way, look up in the current ENVV what the next location is. That's L prime. Okay, and now we're going to be using the old environment, ENVV prime, that was in place at the time the declaration was made. And that may be, doesn't include declarations that came later. So we need to make sure that we don't sort of clobber them by having our next variable pointer. Like this could be a begin end block that allocates more storage. If next stayed back where it was, we could end up writing over memory and then exiting, and would disappear. And then when we end, we have the same amount of memory that we have, but he has to update this. That happens because for us, because that's in the store, and this does not change the store. But we haven't gotten enough stuff here. When we call ENVP, when we look up P in the proc environment, what we're going to get back is this. And so now, what do we want to do? Well, we want to update this environment. Instead of using ENV, maybe we could do it down here. Let's update it now so that X, which was the formal parameter, points to Y, which is the actual, or the formal argument points to the actual parameter. So now what do I want to do? I want to say ENV, let's call this one double prime. And we'll call this one prime is equal to ENV double prime. So that's the environment variable and procedure that was in place at the time the declaration was made. And what I want to do is I want to set the var part so that, oh, how do I update that? Var is equal to insert, and what do I want to insert? Every time I see an X, when I'm evaluating this at the S, the body, I want to use the location of Y. So I need to look up in the current environment Y. That's what he's doing here. He looks up Y in the environment at the time the call happens. So the environment at the time of the call this is my ENV V prime up here, and or down here, it's my ENV. I look up Y. That's going to give me a location, and which environment do I want to update? I want to update the var part of ENV double prime. So, you know, this record update notation is potentially trouble. You know, you might want to say, like, write a little function called update var env, and you give it an X and L and an environment to update, and then you say, okay, update var env is equal to. If I had this function, then up here I could write I don't know, maybe this would have been a big, would have helped people. Update, maybe update var env. And so what is the thing that I want to update in this case? It's X. I want to add an entry for X. And what's the thing that I want to put in there? I want to put in whatever the value of Y is. Oh, this should be a bang. I'm sorry. So this should be to look up, apply the var function to env, and that's going to give me a map, and I look up Y's location. So I'm updating X to point to Y's location, and which environment do I want to do it in? Well, in this case, I want to do it in ENV double prime. So now I've got, this becomes a double prime, and this becomes a double prime. So I don't know, would that help? Don't all scream and holler at once. Does this make the code more readable?
For me, yeah, I always like to have wrapper functions and encapsulate them and stuff like that. It makes it way easier for me
to read. Instead of trying to use the kind of native raw record syntax from Haskell. I mean, this is the same as this. But of course, you know, and then you could have a lookup, you know, so like you could put this up by the environment declaration. Where's that? Here it is. So we could make like, you know, an update. And then we could have an update proc env. And that one has a P, and then it takes three things, right? An S, an X, and a E, and the whatever the environment is that we want to update. And proc is equal to, how come that's not turning? That should turn var. What's going on here? Okay, anyway, is insert for P S comma X comma E, and I want to insert that into the proc env part. Now then we could have like lookup and what do I want to look up? I want to look up some X in an env, and so then all I do is I just say var applied to env bang X. And then I can have lookup proc. Now, I don't know. I think there's a balance. You know, the name of the procedure is, and then this is proc. And then we might want to have a lookup in the store. So this one here becomes, oh, and maybe do we want to have the arguments? What order should they go into? So, you know, like, I don't know. So this is a lookup var env. And by that, it's with X and env. Now, maybe we want to have a lookup store function also. And that one we want, you know, a loc and store. And it's just equal to is that right? So now then this one becomes, see, I don't know that this is helping. Look up
I
in
don't
this.
love it.
You do?
No, I don't love it.
Yeah, I don't know. It looked kind of ugly to me, but okay. I mean, if you're going to do it, you got to do it everywhere, though, right? Look up in the store, this location, I mean, maybe I should, but it could be that maybe I could make the names more helpful. And what store am I using? STO. So maybe instead of like lookup store, I could say like, or like instead of lookup var env, what am I really doing? I'm looking up the var location. And instead of looking up in the procedure in env, what am I doing? I'm kind of like looking up the proc def. What do you think? I don't know. I mean,
I think it's just, I think you have to look back and see what each one means and stuff is, I don't know. I guess the name helps, but.
so then this would be lookup var location of X in env. And then, I mean, maybe this is lookup loc in store. I don't know. This kind of thing can go on forever, though, right? So anyway, all right, let's have a vote. I don't know. Is there a way to everyone who likes? Oh, there's chat. Uh-oh, Parker's not that good at. What's so weird at 12:56? All right. Can you raise your hands if you think this is better way to do it? If you like this, adding these more descriptive terms for sort of standard, you know, maybe hard to understand notation in Haskell. Okay. I see 6 hands, but maybe I can't see. How come I can't see everybody? Okay, raise your hand if you think it was easier before. Only Isaiah. Am I missing something? Okay, that is everybody.
I thought it was helpful with the lookup, the variable environment and the proc environment, but otherwise it just becomes a little like just more keystrokes, honestly.
Yeah, there's a trade-off. Maybe, you know, I do think one thing is that the bang is an operator that's in the, it's an unsafe lookup. Your program will crash if the thing you try to look up isn't there. So like this S bang, you know, or store bang loc, that's going to crash. So you know, you might not want to do that unless we write a type checker for this language. We could write a type checker. That's probably what we should do next after we do this, is so that we can be sure that the evaluator, or, you know, these semantics will always work. If this program is not well typed, it's meaningless. And so we should maybe write a type checker next, and then we could use this bang thing safely. Okay, so update var environment, update proc environment, look up loc, look up proc definition. Okay. Look up in the store, look up var loc of X in the environment, Oh, sure. Okay. It's interesting, right? It's only in the variable command of big step A where you actually do that. Now, in assignment, you do kind of the same thing. This is lookup varloc, right? Yeah. Yeah. Does that seem right? Lookup varloc. Yeah. This is lookup store. This is lookup proc def of P. And this one is lookup varloc of Y in ENV. So I don't know. I mean, maybe it's okay. Now, did I? Okay, so I could use this one also down below, right? Update proc env is here, I can say. And the proc that I want to update, the name of the proc is that sxenv. And it's in env. This one here. Oops. Maybe it's not actually longer in some cases. Okay, where are we at? Okay, let's see. Uh-oh, this one here probably is update store, next look with that value in store double prime. Okay. And this one is update store. with the value of, okay. All right, well, let's see if it compiles. I don't know if that helps or not. Uh-oh. $152. I hope there's not too many of these. That looks like that's a problem. All right, I broke it. Update store. I want to look up the var loc of X in the environment, and it's expecting, oh, didn't I write an update store? Oh, lookup store. I didn't write an update store.
See, if we never made those helper functions, it would still be good to go.
I know, we'd be rolling right along. So what are we going to do? We're updating a store. We're updating a certain location with a certain value and in a store, and it's insert loc KSTO, I think. So that
I think you two are just smarter than the rest of us and are able to read that better.
all right, are we? No, we're not. It's not a matter of intelligence. I mean, well, look, last time I couldn't write imperative program. All right. It's just what you're familiar with. So now we've got this thing loaded. Like, what could we do? We could, I don't know, is there more BIPS stuff out there? Tests. Oh, this means I got to write my programs and put them in a file and then parse them. Uh-oh, and that parser's not going to work with the parameters. All right, so that's not going to work. This is actually, though, probably useful. And in fact, I can put it up with the store stuff. It's just a function to help you display the store. I think. I mean, I could just, I don't even need that, I don't think. All right, let's go down here and let's try something. So what is our program going to be? We want something pretty simple. Proc P X, let's see. Big step decals. proc, the name of our procedure is P, the name of the parameter is called X, and the body is to say assign, oh, we're almost out of time. Well, we can at least see this, X multiply Vx n 2. Okay, that's my program. And now I need, okay, and I gotta have a list of declarations. So this has to be like this. And now I need a environment. So I can say like env0, I think is the empty environment. And I need a store, which is called S0, I think. It takes a list of declarations paired with an environment and a store. Okay, what am I doing wrong? Oh, I got the wrong. Is it num? Aha. Okay, so we got an environment back. We declared no variables. We declared one procedure. The name is P. The statement is this. The formal parameter is X. And the environment that was in place at the time that the procedure declaration was seen was the empty var and procedure environment. And then the store that gets returned is this one because that didn't do anything. All right, I guess I'll let you go, although I can stick around maybe and do a few more examples. All right, maybe I'll give you this code. So this we didn't do a call yet. We need to check the call. So then we got to call that thing. And so we need to write a better program, but maybe I'll put this code up on the lecture for today with the video once I get it up. Okay.
Do you have a separate Zoom link for your office hours, like in the syllabus or something?
I think it is in the, let me just, yeah, I don't know. I didn't really do that right because they are different depending on, put that down. I can put the Zoom link into the chat if you want.
Oh no, I have it right here.
It is in the syllabus.
Yeah, I just found it.
Okay.
All right, cool.
Okay. All right. Do you want to see another example? Anyone? Or do you want to just, yeah. I'll send it to you. Okay. Talk to you later. Bye.